session is on increasing efficiency and productivity in smart factories, hosted by Cisco Meraki in collaboration with Industrial Transformation Asia Pacific, also known as ITAP. My name is Nisha and I'll be your host for today. Next, I would like to run through some housekeeping announcements. For the Q&A session, please post your questions you may have using the Q&A chat function below. Kindly remember to mute your microphones to ensure no interruption during the presentation. Thank you. Next up, I would like to invite Mr. Darren Sia, Portfolio Director, Industrial Transformation at Constellar, to present his opening remarks. Darren, over to you.
Thank you, Nisha. Good morning, ladies and gentlemen. Thank you for joining us today at this web engagement session on increasing efficiency and productivity in smart factories, brought to you by Cisco Meraki. Industrial Transformation Asia Pacific is proud to partner Cisco Meraki for this session. Amid a global manufacturing slowdown and rising inflation fears, digitization is widely recognized as the key to surviving new challenges. To achieve higher productivity and a more significant competitive advantage, manufacturers worldwide are accelerating their transition to smart factories. Together with Cisco Meraki, we, as discussion enablers, see a crucial need for businesses to be empowered by Industry 4.0 to control and better understand every aspect of their operation, leveraging on instant data to boost productivity, improve processes, and drive growth. Today's session is crafted specifically to address these challenges. To continue your learning journey on I 4.0, join us at Industrial Transformation Asia Pacific 2022, Asia Pacific's leading advanced manufacturing event at Singapore Expo from 18th to 20th October 2022. Designed and curated to help manufacturers start, scale, and sustain their adoption of Industry 4.0 processes and solutions. Meanwhile, please enjoy this session, and we look forward to seeing you at ITAP 2022. Back to you, Nisha.
Thank you, Darren. Let's start our session by welcoming James McKee, Meraki IoT and Edge Intelligence Product Sales Specialist from Cisco Meraki, to deliver his keynote presentation on accelerating the future of smart factories with automation. A gentle reminder, please post your questions using the Q&A function at the bottom of your screen. James, over to you.
Thank you, Nisha, and good morning, everybody, and thank you for joining this session today. So the topic we wanted to cover off today was accelerating the future of smart factories with automation. And I think Darren's provided a bit of a framework as to what challenges manufacturing are going through from an industry point of view. So what we wanted to do was kind of just revisit those points and I guess identify what they are. Look at how customers are leveraging platforms like Cisco Meraki to actually help solve for those challenges, but also how they can actually look to say take traditional services that they're familiar with in the manufacturing space and essentially drive them through a transformation paradigm to get new lines of value or new valued outcomes in the deployments. So we're going to kind of touch on what some of those might look like, some of the various use cases, also some customer success stories in that space, to give you all a bit of an understanding as to how we're seeing these tools leveraged in industry to drive success. So on that note, what is, just to go back to Darren's point, what is driving manufacturing transformation? I think, we fundamentally have a whole range of different uncertainties we're dealing with, right? And I think everybody is familiar with what these are. And I guess what this is driving is things like the Industry 4.0 digitalisation. We're looking at ways of being more effective with the supply chain that we have access to, and obviously working out how we can actually better address some of those challenges by gaining visibility into, say, different things that are going on in manufacturing spaces. And we're obviously all aware of the imperative to manage risk in the context of security. So that's also how do we actually implement some of these transformational style services whilst underpinning requirements around risk and security. How do we address the knowledge gap that we see in this space? I think fundamentally, we're all aware of the challenges that we're dealing with around finding the right talent to actually execute on a number of these strategic goals our customers have and we have, but also finally, how do we also do this in a way that is in alignment with green or sustainability initiatives that we're seeing both boards and executives request. So we're seeing a lot of different asks, and ultimately the way we typically look to approach technology on these spaces is to how do we offer a platform that can essentially underpin and drive a range of these outcomes in an effective, safe, and scalable manner. So I guess if we look at what's the key driver in this space, we're really trying to obviously maintain competitive, advantage in the manufacturing industry, deliver agility, and execute on those strategic initiatives that businesses are looking to achieve. So I guess what are the questions we see customers ask when it comes to these sorts of things? Well, first of all, if we look at technology in general, and especially in the say the IT and OT space for that matter, complexity is a key challenge. Capturing the data and that systems create, and actually providing those to the right stakeholders in a secure and scalable way is another challenge. Driving those sustainability objectives. Automation, one of the key areas we're going to cover off today, is also another piece that actually allows us to drive value effectively and quickly at scale. And then essentially, how do we then take that as the starting point and look to not only deliver on, say, traditional use case outcomes in manufacturing, but also leverage some of those, those transformational requirements that have been defined as being strategic objectives. So I want to give you a view as to what some of those might look like as well. So you can kind of see those key objectives that we're looking to drive pretty much apparent across all technology installations, whether that be manufacturing or otherwise. But the key lens we're going to focus on here is that whole smart factory space. How can we actually look to take what we have as a platform and apply it to some of those key areas? So really what we want to touch on is Meraki for manufacturing. What are some of these experiences that we can deliver, and how can we deliver on the key needs, say in traditional manufacturing sense, but also in that transformational agenda sense that addresses those key sustainability and I guess industry-wide challenges that we called out at the start. So we've talked about the why. I guess let's pivot to talk a little bit about the how. What are the tools that we can actually leverage to do this? Now, whilst my responsibility is to look after the Meraki IT portfolio in the APJC region, one of the things I obviously leverage to actually execute on those services is the broader Meraki platform. So we're going to just touch on that at a high level, but I also want to touch on the toolkit that affords for businesses to actually achieve some of these goals. And I'm sure you're all very familiar with concepts like APIs, ecosystem, i.e. working with other partners to achieve goals, based on their specialist expertise and things like that. But also, how do we actually realize value faster? And this kind of aligns back to that agility sort of goal that many businesses in manufacturing are looking to achieve. So what we're really seeing is a number of these services that we're very familiar with often in the IT space, but also kind of stretching into the OT space. And before I move forward, I wanted to just touch on that a little bit. One of the things that's really interesting in a lot of conversations we have with our customers is that IT/OT conversation is, hasn't traditionally been fostered, or often there's some conflict there that needs to be addressed. So we're actually seeing ourselves as almost facilitators of actually bringing these teams together to understand where joint goals can be achieved. And I think one of those key messages we look to drive is understanding each of those functions' roles in business, and making sure that we kind of look for some aligned strategic goals across both IT and OT teams to get the outcomes that both functions within business need, but also at the same time deliver an underpinning platform that allows the business to be creative and drive those broader transformational style outcomes that they're looking to kind of hit on. So they're the observations that we typically see, but where people struggle a little bit is how do we take those tools then and then turn them into value in the manufacturing space. So let's actually drill into that a little bit. I guess first of all, if we look at Cisco Meraki as a platform, what Meraki is looking to do is offer, as I call it here, a secure cloud-based IT platform that is pretty much being developed from the ground up to deliver simplicity, but also provide a future-proof digital transformation platform. So there's a few key things that this touches on based on those key requirements we called out at the start. First thing is allow technology to be more simple and effective, so reduce complexity. So that brings a few things in place. It allows us to often deliver solutions more effectively and faster at scale, allows us to realize value more quickly, but it reduces risk. And these are some of the key goals that businesses are looking to achieve. Delivering these solutions in a way that actually meets our security requirements. That could be around risk, it could be around vulnerability management, it could be around software management and patching. And if we look at manufacturing, traditionally we've seen a lot of systems put in place that are standalone, that are air gapped, that may not necessarily run the latest software because they're functional, they're fit for purpose based on the goal they're looking to achieve. But those sorts of approaches don't necessarily provide the goals of transformation for business. So it's like, how do we kind of stitch those things together whilst maintaining the outcomes that, say, the AT side of the business need to achieve, but then also deliver the risk management and service capability that the IT side of the business look to achieve. And then it's like, how do we then take those things and automate them, modernize them at scale? And I think at scale is the key point to call out here. If we look at many manufacturing sites and deployments and the distributed nature of a lot of them, it's, we can't just think about it delivering a siloed solution. We need something that can essentially deliver that value across that whole paradigm. So it's really about providing those services to achieve those goals. So really what I want to do now is drill into what opportunities we have to actually revisit first of all those four key pillars at the start, but also look at what they mean in the context of problem versus solution, and we'll explore some of the use cases that align to that, and then I'll show some examples around how we can actually execute that in reality. So if we look at challenges, and I'm talking about this in a bit more of a generic sense rather than IoT specific sense, some of the key challenges are just getting visibility of what's going on in the space, especially if it's remote. So it's getting access to the right information at the right time. It's then actually providing assurance around the services that are delivered in the manufacturing space that are needed to allow the business to deliver on the key imperative, which is often producing goods or services in a way that delivers effective yields, meets the needs of not only customer demand, which as we called out at the start is challenging in the supply chain space at the moment. So we need to be effective in everything that we deliver. So it's about providing kind of insights and guidance that ensures we're on track to deliver on our needs. So we have opportunities, I guess, based on these challenges to look at doing things maybe in a better way, providing better ways of delivering, I guess, the underpinning services that provide a space or a factory environment to deliver these outcomes. So is the space safe and secure? Are our workers safe and secure? So there's some of the traditional goals that we're looking to achieve, but then how can we take some of these say toolkits that we have and we could extend that to even look at things that are a bit more topical in the market today, like AI and ML, computer vision, to actually maybe drive productivity improvements in manufacturing. Drive automated insights for business to ensure that there's timely access to information that matters to deliver on the goals that the business is looking to achieve. So we'll have a whole range of different needs and goals that we need to drive, and we do this in a range of different ways. On the previous slide, I touched on things like APIs, ecosystem. Really, what we need to do is take the resources that we have available to us that are appropriate for the problem at hand, and then essentially leverage them to get the outcome. So, we work with a whole range of different partners in the manufacturing space to help drive those outcomes, and they could be across things like access control, i.e. access to buildings and things like that. It could be across computer vision outcomes for quality control purposes and things like that. I.e. we've got customers doing things like assessing components with cameras to determine that the appropriate quality controls achieved in the production of a good, for instance. So it's really taking a toolkit to apply them to traditional processes whilst giving a broader, rich tapestry of insight and capability and ability to deliver value. So let's touch on a number of those use cases and actually see what they might look like. And these are really to prompt some thinking and thought process around where people can start. I think one of the often the key challenges we see with customers when we have this conversation is like, well, we've got a lot of existing systems, but we can't just go and kind of change everything at once. What are maybe some key goals we could achieve, quickly to help us on that journey and achieve that that transformation agenda that many businesses are looking to achieve. So I guess one thing that we've all become very familiar and comfortable with is, remote working. But I guess the same thing can, be present in manufacturing. It's like remote operations. How do we make sure we've got insight around what's going on the smart factory floor, and how do we actually use that as a means to drive particular outcomes? So actually securely delivering services like this for basic connectivity, often proved difficult in some of these spaces. So what we're trying to provide from an architectural point of view is that connectivity piece, which then basically becomes the platform for a range of those other transformational agendas we see in the manufacturing space. So it could be, monitoring that space with smart cameras, for instance. It might be determining whether service is up and operational in order to deliver, say, the appropriate level of risk for a space, or providing some sort of feedback loop around compliance. Are we achieving what we need to achieve as, say, workers move around, as, say, a factory floor space in the context of, are they doing it in a safe manner? Are they doing it in alignment with, say, policy around, safety and security? So you can see it's about taking, I guess, digital tools that may not necessarily be thought of in the context of manufacturing, applying those for operational processes, new capabilities in a way that is valuable, scalable, and delivers on the needs of business. If we move forward to, say, another, I guess, perspective, we can look at things like sustainability. This is a really interesting one in that, it's coming up in nearly every conversation I'm having with customers now. And it's really about, well, how do we know whether we're actually running a service in a sustainable manner? And I want to touch on sustainability in the context of what the Meraki IT portfolio does as well, because it's not all just about, necessarily reporting on things that might be tied to a sustainability agenda. It might be about reducing the footprint of a particular service to achieve a sustainability goal. An example of that, for instance, is, I'll talk about our smart cameras briefly. One thing we've approached, in the smart camera space is to essentially remove a lot of the moving parts, i.e. things like, NVRs and DVRs, which are typically the storage subsystems that video surveillance solutions use, and then also the broader, servers that are required to actually view that data. We tried to make that simple. So that in itself, removing those moving parts and the additional infrastructure that's required to actually deliver these services helps drive that sustainability agenda. We also might want to understand the locations where those services might sit. We might want to actually use a sensor to actually monitor, say, the temperature and humidity in that space. We might want to actually detect whether, say, a water leak or some of the sort of risk management, risk function that needs to be reported on in an automated way to address that risk. So it's really about starting to stitch these tools together in a way that kind of aligns to, say, existing functions or processes that we need to deliver, but in a way that's, holistic, tied into a single, architectural solution that gets these outcomes, but also allows new future outcomes to be addressed. The safety and security one's always an interesting one, because I think all of you would agree, in every business you walk into, whether it be manufacturing or otherwise, it doesn't take long for you to look up and see a camera somewhere. And our cameras have traditionally been used to just monitor behavior, look for, safety and security risks. But cameras now in this digital transformation age can be used for a wealth of new things. Yes, that'd be great to identify whether there's a potential risk, but we might want to use cameras to determine, do the workers on our smart factory floors have the appropriate PPE in place in order to deliver the service that they require? Is there a problem with, say, some of the machinery, say, operating temperatures in that space that we might need to report on in order to ensure that we don't have any downtime? And I guess this kind of comes back to that supply chain piece, right? We need to be sure we can do the best with what we have in order to make sure we're getting the outcomes that we need to deliver as a business. So there's a whole range of different tie-ins here. And we have a range of different ecosystem providers that specialize in different manufacturing outcomes to help kind of underpin these new lines of value. And these are often being uncovered by businesses as well. It's not always what we think is appropriate. We kind of provide a platform that allows customers to solve for their own unique problems. A good example of that is custom computer vision, for example, and I'll touch on that briefly in a minute, so you can kind of see how these tools can be used, because I really want you to take away that toolkit in your mindset. The other piece, which is very relevant in the smart factory piece is, asset management. How do we know where devices are? How do we keep track of, say, high value items that are critical in, say, the manufacturing process to deliver products, etc., whatever we're looking to actually manufacture. It's about starting simple, but actually providing, that rich insight and data to kind of get there. So these things become, really, I guess, good insertion points to start having a conversation with the various stakeholders that run these parts of the business across both IT and OT to say, well, where can we actually work together to actually start to get some quick wins for business that help, first of all, maintain the service that our customers expect, but also essentially grow and extend that in a way that delivers, better value for business, better service for customers, higher productivity, reduce risk, all these sorts of goals that are very, topical in the manufacturing space. So what I want to do now is, as I've touched on some of the key use cases, I want to really just kind of show you what some of these actually kind of look like and how we can essentially enable, factory of the future outcomes. So I'm going to do a live demo. Live demo is always great because, everyone thinks, oh gosh, I hope this doesn't go as expected, because it's always fun to watch a demo, not go right. But I guess the good news for you today is that I do these typically all the time. So I trust this will work well for you. But what I wanted to touch on first is just essentially a view of cameras in the context of a deployment site. Now, I want you to think about this in the context of a manufacturing floor. Now, the camera I'm going to actually click on here is actually a camera that sits in my home office in Melbourne. Now, I'm actually presenting to you today from Sydney, but I guess what I'm really demonstrating at this same time is the fact that we can get access to the information that we need from wherever we are in a secure and an appropriate manner. So what you're actually looking here is the field of view of a particular camera. Now imagine this camera's on a manufacturing floor. What I really wanted to call out here is the cameras by default can see things like people, vehicles, but that's great in a simple context, but we might want to see more based on the use case that we want to solve for. So we can do interesting things like create unique zones in the field of view. That imagine this being a manufacturing floor, right? We might want to say, well, this area here is a safety and security risk. So we might want to just call this, like safety area 1. We might want to add that as an area of interest in our configuration. And then what we might want to do is actually start to monitor using, say, analytics, where people are actually going in that space. Or we might want to actually see how do people move within that space. But by leveraging things like heat maps. So I guess the point I'm trying to call out is we've got a rich toolkit that can be applied to the smart factory outcomes that many businesses are looking to achieve that may not necessarily have been thought of as providing value and insight in this way. So it's about actually taking that information and leveraging that in a way that's valuable. Now that's the simple starting point. What I really want to show now is some examples of how we extend that. And I guess this is where it starts to get a little bit more kind of interesting. The first one I want to touch on is turning up a service like this, right? So getting access to value quickly, aligning to the agility agenda, delivering a service at scale that's secure is traditionally difficult. So what I'm going to do, these normally, I play these videos which I put together for a number of different customers because there's some basic concepts people want to understand on how to achieve. So this one here, for instance, is showing you how you can actually use automation to actually provision a service from scratch. So we're actually configuring 10 cameras here in this particular example. Now, you saw the dashboard that we use to actually view cameras and the rest of the portfolio for that matter. What we're actually doing here is we're basically leveraging the power of that API ecosystem to actually turn a service up from scratch before we even go and plug any bit of infrastructure in. So if we think about building, say, a manufacturing plant, augmenting a manufacturing plant, what we might want to do is actually deliver that service at scale, but also kind of coordinate when it's appropriate, i.e. might be out of hours or maintenance period, to actually get those cameras up online. So what you've seen here is we actually built those cameras out automatically. We've added them into a network, which might be the manufacturing plant, and we're basically, laid them out in a floor plan, on a map. We're achieving essentially all the goals that we would need to achieve on a manufacturing plant without even going there. So you can see it actually allows us to quickly get most of the baseline capability around delivering a service completed. It's then about providing visibility to that, then arranging with, say, the installers, the typical plant owners to then go and say, install a camera, adjust the field of view and get the outcome that we need. So you can kind of see there's a range of different outcomes we can achieve there. If we flick a step further and say, well, once we've got those cameras in place, what if we actually want to monitor what's going on? So one of the cool things that cameras can do is whilst they see what's going on in a field of view, we can actually make them see like humans in a way. It's like see things that are important to us, so we can drive, say, process automation or automated feedback loop around, say, incident response and things like that. So this example here that I want to quickly show, what this is basically doing is looking for an event in the field of view on a camera. So you'll see here in the field of view, what I'm basically doing is detecting whether or not a person's in this space. Now think of this like, say, a spill or some sort of safety zone breach on the manufacturing floor. What we could actually use the API that I'm referring to in this instance, which is called the MV Sense API, is I'm actually using it to color a space. And you'll see on the left-hand side, we've just got the security incident detected. And you'll see I've actually qualified different objects in that space. I've done some object detection. I've actually done some facial analysis, all in accordance with privacy law, of course, just to see, well, hang on, what's the actor that's in scene? Does this match what we expect to be there? Does this warrant some sort of follow-up? And finally, though, we've also got the ability to then review that footage. So we're kind of taking an output of the system, providing insight to, say, process owners or service owners to deliver a particular outcome that is needed, and then giving them the ability, if they're approved for access, to actually review that information and drive, say, a process automation. Where we're seeing this a lot is around that quality control piece in the factories, getting the outcome that we need, and then driving that forward in a quick and effective manner. And I want to take that. We've got two more quick demos I want to kind of cover, and then we'll kind of wrap the kind of story up around platform. But there's two more use cases I want to share. One is, well, once we've got these capabilities in place and we build some level of maturity, what if we wanted to extend that to do some really interesting stuff, like, say, look at componentry going along a conveyor belt to determine, first of all, that it meets our manufacturing requirements and tolerances, helps us achieve the appropriate yield that we're expecting from, say, a manufacturing process that we might have, or solve for, say, some other interesting use case that we haven't thought of yet. So what this example shows us is deploying a custom computer vision model. Now, I'm not going to go through the process of creating a custom computer vision model in this session. We just don't have the time. But computer vision allows us to actually observe and detect things that we often can do as humans, but we could actually train a machine to do it more effectively, and I guess not miss things. So it becomes more manages risk around false positives and things like that. So what we can basically do is train a model to a particular efficacy level. A lot of people typically are looking for 90+% efficacy around a particular detection. Then they actually want to start collecting that information in real time. So this example is showing us taking a model, and I'm using an open source model in this example, which takes I spoke about people and vehicle detection earlier. On your manufacturing floor, that might be useless. We may not want to actually detect that. We might want to detect machinery from, say, an asset tracking point of view. We want to detect product that we're producing. We want to detect tolerances relating to a product. If we can actually train a model to identify those things, what this tool allows us to do is then go and apply that to our cameras at scale securely, without essentially having to go and build out new infrastructure, which is often a barrier of entry to achieve this. And then we can do detections like this. So instead of detecting people and vehicles, you'll see we're detecting people here, chairs, dining tables, a whole range of different things. So we can basically use that as a means to color a space, provide a feedback loop, and drive a particular outcome. And I guess finally, this data can also be used to understand, say, a manufacturing floor in a better way. So this example shows both cameras and sensors providing what we call MQTT telemetry data. Now, I'm sure some of you on this session are aware of what MQTT is, but I'm just going to provide you a quick summary. It's basically a lightweight telemetry protocol. Apologies, I'll just throw the volume down. That allows us to actually see what's going on from a sensor. Could that be a camera? Could be a sensor here. And you'll see on the right-hand side, we're actually looking at that in real time. And you'll see here, I have a funky little Meraki fridge, which I'm going to open. And what you'll see is we have a door open close event be captured here. And also have a temperature sensor sitting inside the fridge to determine the temperature. But all that information can be provided in real time. And at the same time, we can actually collect things like light levels, audio dB levels, say from a factory floor to determine whether the space is safe for our staff that are sitting in those areas. So really what you can see here with that thought process and the understanding that we can actually capture all this info, we can start to color some really interesting experiences and outcomes with this data. So as we look to kind of wrap this up, I want to touch on a few customers success stories where we've got customers going on this journey, but picking things that make sense for them as organizations, and then leave you with a few key takeaways to kind of think about how the adoption of Meraki IT services could be relevant in your smart factory. So a couple of quick customer stories. We've got businesses like Bossa Nova. They actually put sensors in to detect whether or not their infrastructure was running appropriately. Now, a single event easily and quickly pays for the installation of things like sensors, and obviously turning that up in a quick and easy way is super valuable for businesses. So it's about actually monitoring those assets. We've got Maxion. It's augmenting process again, so it comes back to automation. How do we actually drive an outcome that uses all the various components that we need on the manufacturing floor to improve the experiences of the manufacturing floor in the context of things like smart factories. So it's about using the toolkit. Finally, we have a business like DB Schenker. It's like, well, hang on, these things are great to do, but they're often really difficult to manage at scale. So this example, it's really just calling out the centralized management value that we can have to drive these experiences at, say, a range of different manufacturing plants around a region. So it's about kind of stitching that all together to continue to drive that value. So I want to kind of close up now and really just give you a few key takeaways to think about. But I also want to get you to think about any questions you may want to ask on the back of this session. Obviously, I've covered a lot in a really short period of time, but really what I want you to understand is that we're trying to bring a platform to customers that allow them to achieve their key goals whilst managing some of those challenges that we called out at the start of the day. And the things that I wanted to really call out were things like, let's look at the physical security space. Where can we start to actually put cameras in place that meet the risk requirement needs of business, but also then solve for you say some of those cameras as sensor use cases. Things like connectivity at scale. How do we deliver connectivity for these services, i.e. provide the underpinning platform to get the outcome that we might need? How do we look to drive things like sustainability initiatives and get a view as to, say, infrastructure operational profiles that are sitting, say, on the manufacturing floor? How do we actually look, to then report on that and identify areas for improvement? And I guess a key area where we're seeing that is even things around, ASHRAE, which is essentially an energy usage standard, which allows us to determine whether or not we're effectively cooling, equipment, or whether we could actually reduce our energy cost in achieving those outcomes. So it's really about understanding accessibility, scalability, security in the context of the key goals we're looking to drive in smart manufacturing. So that's pretty much everything I wanted to kind of cover off in this session. I'm just on time. So look, if anybody has any questions relating to this or would like to reach out, please do either send them in for the session and we'll make sure we get back to you, or reach out to any of your your broader contacts and we'd be always happy to help you with that. And on that note, I'll hand back and say thank you to everybody for listening.
Thank you, James, for the very insightful session. The use cases at the end with the some of the examples, I think it will really help the participants to understand better on how these technologies revolve around them. Thank you for that. Our next session is a panel discussion on future-proofing your smart factories. Right after James McKee, who have presented his keynote, we're going to take a deep dive into some of the challenges that you face in future-proofing your smart factories, and this would be a great discussion, moderated by Satvik Rao, Principal Director, Industry X from Accenture. A gentle reminder, please post your questions using the Q&A button at the bottom of the screen, and our moderator will read them out to our panelists during the discussion. Satvik, over to you.
Thank you, Nisha. Hello and welcome to the panel discussion. So as all of we are seeing around what is happening in the post-pandemic world, both discrete and process manufacturers face unprecedented demand from a sky-high customer expectation to the drive sustainability. So not just about meeting the demand, but also how do you drive sustainability in operations. So manufacturer needs to boost the efficiency, flexibility, and safety to survive in a world of growing economic and environmental and regulatory pressures. To gain the visibility and control they need, they must push beyond single site Industry 4.0 digitization efforts to optimize the entirety of their production, workforce, and supply chain networks. But with operations and assets spanning across multiple sites, hampered by massive labor shortage, supply chain disruptions that we see, legacy technology, transforming to a smart factory or a factory of the future become a real challenge. Today, we have expert panel to discuss some of these key points and share some best-in-class examples on navigating the smart factory complexities. With that, let me welcome and introduce my panel. With us, we have today Dr. Prem Prakash Jayaraman, is an associate professor and director of Factory of Future and Digital Innovation Lab at Swinburne University of Technology. He leads industry-funded groundbreaking research in Internet of Things, IoT, mobile and cloud computing to co-create novel solutions underpinned by digital technologies, solving industry problems and aiding the digital transformation journey. So he has also co-authored 140 plus journals in this space, a well-known author in this space, and attended many conferences, presented in many conferences, and a book chapter in highly ranked venues and in the above research areas of Internet of Things and Factory of the Future. Welcome, Dr. Prem, to the panel. And we also have Mok Han Yong, is the Chief Strategy Officer of Onwa Technology Pte Limited, OWT, and he has assisted in achieving strategic milestones, including winning the Enterprise 50 Award, E50, which is a well-known award given to SMBs in Singapore, 2015 and 2016 consecutively. Han Yong managed both finance and project departments of the company and leads the automation and innovation initiatives of OWT. Welcome, Han Yong, to the panel. We have James Mackey, leads the Cisco Meraki IoT sales business across, who just spoke at depth about some of the use cases and the initiatives that manufacturers can do as part of the journey to future of the smart manufacturing space. So with that, I will open the panel. Maybe my first question is to James, for you, because you just concluded your sharing your thoughts. What are some of the quick wins could the manufacturing industry implement from the other sectors, right, who have been doing similar things? They're ahead of the curve when it comes to the smart technologies, right? What they can learn from other industries. Can you shed some light on that, James?
Yes, look, thank you. I think that's a great question. Fundamentally, as you've seen in my previous conversation just earlier, one of the things that is often a challenge is, I guess, broaching the conversation between IT and OT. So in some different verticals, what we're seeing is, I guess, transition of service ownership, say from OT part of the business to the IT part of the business. Or some sort of, say, ownership from a functional or service perspective around the function, but then ownership of IT to actually run the infrastructure required to deliver that. So that pretty much affords an opportunity to look for synergies, right? So one of the things we typically see is customers kind of start with the basics. So if I look at, say, example, one of my particular customers who it would be not appropriate to name, but what they're looking to do is basically take the basic use case of physical security that they've leveraged and delivered in a particular way for a very long time, which poses them risks around reliability and assurance and things like that. What they've actually looked to do is work with the OT side of the business to determine, well, hang on, you have parallel systems that deliver similar sort of outcomes. How do we start to stitch that and rationalize those into, say, one system that delivers on the goals for risk, compliance, security, accessibility across different stakeholder groups, What I mean by accessibility, it's not just, if we look at that as a function, so if we look at security as a function, typically those systems have always had, say, a camera operator drive them, right? So you typically haven't had business stakeholders or say people who are delivering, say, manufacturing outcomes get access to that info, right? So, you know, it's really about actually opening up that to say, well, hang on, we've got this data that we can collect that we can then drive. So these sorts of crossover points, I guess, afford an opportunity for business to actually, you know, go, well, you know, we could rationalize this and all win or all achieve some outcomes. So I think they're the areas that I'll be looking for, the areas where there's by a synergy across different functions of the business. I think there's some quick wins, and it's then about broaching that conversation. And sometimes it's tough, I'll be honest, you know, I've been in a number of conversations where it's got quite heated and there's been arguments between stakeholder groups, like there's no way we'd ever do it like this, or there's no, we want to do it this way. And I think, you know, there's no wrong or right answer here. It's really about, oh, hang on, let's understand the perspective of both parties. Let's not assume there's one right way to do it. And I think then we can actually start to find those, you know, outcomes that we can achieve and all gain as a whole. So I think that for me, it's finding those synergies that would be the quick wins, and then looking at a way to execute on them.
Thank you, James. I think, yeah, finding that synergies and learning from other industries and doing that cross-pollination, I think will save time in reinventing the wheel, right? That's absolutely.
Absolutely.
Yeah, thanks. So continuing the questions on the, as we discuss the solution space, right? So maybe to question to Dr. Prem. How have some of the existing solutions that you see can help improve manufacturing productivity is one big challenge, right, for manufacture, especially with the labor shortage and other issues that we're facing in the shop floor. How does the solutions help improving the manufacturing productivity through reducing downtime and increasing the adaptability? Any thoughts you would like to share, Dr. Prem?
Sure, Satvik, thank you so much. And I'll probably actually say James said a very good segue into this. And in his presentation, he had a few good examples of how this could be. From my past experience, bringing this technology together, we have been able to sort of develop solutions that have addressed things like product quality in your entire process-based manufacturing areas. One of the other area that we've done quite a bit of work also is often when we talk about automation or technology, there is the fear that the operator is going to be replaced. And I often start off with my customers saying, or people I work, it's actually not replacing them. It's actually, you know, aiding them to be more efficient, or otherwise providing technology where, you know, things that they could actually put their knowledge in better places that they are. So I think a lot of technology can help with I think James had some examples of the operators in terms of safety perspective, but even in terms of worker performance, wearable technologies have sort of developed quite advanced technologies are there where you could look at safety in terms of people injuring themselves while performing a whole lot of manual operations, and which if you look at a typical manufacturing site today, you know, automation is great. It's existed for a long time, but I know people have invested significantly and still have people carrying manual crates from one place to another because it's just that. And I guess a bigger aspect of this is also around the supply chain, because with the manufacturing, with the digital supply chain, there's a lot of data that exists outside of where things are coming in. So you could look at that to harness better optimized planning and scheduling. And I know a lot of participants here, and most of you would sort of raising the hand with me saying, how many of you still plan based on Excel sheets and schedule your entire thing? While the technology exists, right? I mean, that's technology in terms of automating this already exists, but it's sort of bringing that all together. So, and one of the other areas, of course, the most common one that many people have looked at is predictive maintenance, how you could sort of reduce your downtime and look at this. But the one common thing I always look at all of this is that technology is not the key. To me, it's more about when I always have a discussion with them, within our team, we've got this thing saying, if you apply technology to a broken process, you get a broken digital process. So it's as simple as that. So it's starting with your process, you know, what is your key points that you want to make improvements in? Is it the area of productivity? And of course, there's always cost. The other area, sustainable energy. You know, there is now a lot of work in IoT and also clean energy. where you could look at energy efficiencies. There's a big push from a lot of manufacturers now towards what's called design for sustainability. So can you go right from product design to make it more energy efficient rather than saying, I want to produce a clunky product which is going to produce, thousands of kilowatts, but then can you actually change the entire design right from the design perspective to make it more energy efficient when you're producing it? So I'll stop there. I think, look, I guess with some of the examples that James had, it kind of really provided the opportunities and where the technology is to make those savings. And maybe we'll leave some time for more questions from the audience later on. But thank you so much.
Yeah, thanks, Prem. I think if I have to summarize, it is about the bringing through automation, get more put people where there is value rather than doing non-value add work at the shop floor. And how do you design your products to we call it as design for X, right? Design for automation, design for sustainability. So very good points, Dr. Prem. Thanks for that. Just building on top of what you have said, if I may have to ask Han Yong to add his points on what are some of the lesson learned and experiences and expert insights you have to provide when it comes to future-proofing smart factories, right? From your experience working with your customers, Han Yong.
Yeah, thank you, Savik. Actually, to add on to Dr. Prem, actually, yes, I agree. We are building capabilities is to do a collaboration between our current users with automation so that actually we can do things faster, accurate, and how we can repeat our quality any times we do. So probably I think we have some questions on how we start to plan smart factory. Probably just to share some of our experience that initially we started some small automation projects probably 7 to 8 years ago. Back then, Industry 4.0, I think the term is still not probably started out. So basically we are just doing a lot of lean manufacturing, trying to so-called have our best practices. And then we try to see what is our process bottleneck, solve the pain for our users. And then this is actually how we start to begin this journey. So probably, like James mentioned, from a lot of IoT so-called solutions in his earlier presentation, but I would just like to share how a user can actually start to strategize with what are the resources you have. Probably as for our tech, we are SME. So basically we have limited resources. Therefore, I think we are particularly so-called proactive in looking out with some of the grants available in the market. Especially we are very proactive so-called government agencies in Singapore, Enterprise Singapore, that can help us in terms of grant and a lot of so-called solutions that they share to the industry that we can learn. So probably for a start, we try to see how we can actually, of course, understanding what we can provide to our customer. And then, of course, it has to make so-called investment sense that when we invest in these solutions, actually can help us to scale out and then to probably to provide a competitive edge. So this is one of the things that before you start so-called looking out what are the solutions that is best relevant to our own needs. And then, of course, like I mentioned earlier, is on the identifying of the pain points. What are the process bottlenecks that actually, if you start to improve, you can have immediate so-called gains and returns from these investments. So for my own personal example, actually, I come from a comfort zone. So basically, I initiate a lot of changes in the company. So basically, I lead the changes. So in a way that I have a clear strategy what we're going to do, and then it's a progressive, gradual improvement to the so-called solutions that we actually gain. And then once we have confidence, we can bring in more. So basically, we are trying to integrate with existing equipment, especially for the legacy machines, how actually we can add on to some IoT sensorization, that actually we can start to connect our machines together, giving us real-time process information. What are the machines doing it? Who are doing it? So basically, we have a good control of the information in the shop floor, even while we are remote working, especially during the pandemic time that we have difficulty accessing some information on site. So basically, we are also trying to explore new techniques, especially now, I believe we are going beyond hardware automation. Therefore, we are also looking into software development that actually can bring in to help us do things faster. So I think with Dr. Prem here, I will try to introduce some academic terms. So basically, we are trying to exploit and exploit at the same time. So basically, we term it as ambidextrous strategy. And then this has been proving very successful for our tech. So basically is, last year, actually, I do a job redesign myself. I basically put on myself form a specialized project team just to look into new solutions that actually we can bring in to complement so-called our equipment existing solutions to do a full integration into this plan. So of this, I think, of course, there are a lot of interesting projects out there, so we need to prioritize. So basically, of course, we are doing a lot of traditional cost impact analysis, but I believe as SME in particular, we have to look into the effort and time. So basically, you have to look into the projects, what are the resources you have, and then so-called prioritize on the projects on hand. So basically, I believe for the last 8 years, I've experienced some of this journey. Therefore, I'm quoting a Bosch Industry 4.0 framework that I believe will be particularly useful to the users who are trying to embark on this journey. Basically, there are 6 steps, and then I have actually separated them into 3 tiers. Basically, the basic, intermediate, and expert. So basically, for most of us, I think once we achieve the first 3 steps in basic, I think we should be in a very, very comfortable so-called area. So when first step, probably like I mentioned, the lean manufacturing, how basically we adopt best practices, having the operational discipline, engineering principles before moving on to innovation. So for step 2, connectivity and digitalization, I believe this the IoT solution comes in. How actually we can link up our old machines to new machines, collect and sharing data across the shop floor. So for number 3, once you have the information, I believe users can be alerted and make good decisions out of these measures. So for intermediate, I think these are the steps that when you are ready, when you have enough data, that you can actually start to find patterns and then using AI techniques to interpret the patterns. Basically, it's to finding similarities that you can actually make judgment out of this so-called occurrence with historical data. So for the last expert, I believe it will be an ideal situation that autonomous, that means whether you are confident to let the machines to make decision for you when anomalies happen, that you can actually change your recipe, that actually when machine is behaving anomaly, what users can be so-called working with the machine to change the recipe on the fly. So for this, I believe I would like to summarize it's more of we are using IoT in particular to see, hear, feel, and give us particular good feedbacks to the users on site. That can be our eyes and ears and speak out on the truth on behalf of the team when actually anomalies happen. To see an example, it's a black box. It's a manufacturing black box that actually we would really like to know what happened real time and then how we can actually react and do a corrective action to do things better in the future. Yeah, so I think I'll go back to Sandeep. Thanks.
Yeah, thanks, Anyang. I think you explained the whole journey in a very nice way in terms of how someone, especially SMEs, can start embarking on this journey, right? So many people struggle to start, where to start and how to start. I think you shed light on those aspects. Thanks, Anyang. So there are a couple of questions from audience. Maybe if I have to pick one of them. So one is very specific to a concrete manufacturing. I think how to apply technologies or solutions that we discussed to digital concrete manufacturing to ensure production quality, efficiency, and productivity. So again, it's boiling down to manufacturing solutions related to production quality, efficiency, and productivity. I would like to know if James or Dr. Prem, you would like to add your thoughts on that?
Yeah, look, I might just add a quick note to that. So we've got a customer doing something similar with asphalt manufacturing. So essentially, I think the explanation around life cycle, as in how you apply the technology, I think is super important here. We need to understand the process first, and I think it's not necessarily about taking the turnkey capability. It's like, what's the data that we can collect from these sensors, and then how do we actually apply it to the process? So I think it's easy to go, oh great, is there a widget that allows me to solve for X? But essentially, if we can actually understand, so if we apply this to concrete, for instance, first of all, it's like, well, what do we need to understand about the concrete manufacturing process, and what can we capture from, say, a suite of sensors? Once we start to get that information, we can actually start to use that as the ground truth, and then really apply the tools to provide, I guess, a feedback loop around what we see, and then use that as as a means to kind of fine tune the qualification process around, yeah, production quality. What are the outliers we're looking for? Are we driving a process in the most efficient manner? And obviously we need to then engage with the SMEs who are familiar with the process to actually qualify that, right? It's not, it kind of comes back to, I use the term toolkit quite a bit. And it also comes back to Dr. Prim's point. It is exactly a toolkit. It's like, well, how do we take these things, which can be quite simple in isolation, but then actually deliver them on or overlay them on say, our existing processes, the process we might want to change and transform. So I think, it's really about defining it up front, getting the toolkit or understanding the toolkit, and then really applying it. So the way one of my customers who's doing the asphalt manufacturing piece, what they did first of all was, what's their existing process? So they essentially augmented that with camera feeds. Then they said, well, hang on, what can we tell about the way in which in which asphalt's being delivered, say, onto trucks, that allows us to determine quality, type, efficiency, productivity, and it'd be another consultative process to kind of align that to concrete. But there's no reason I think why we couldn't do that. So hopefully that gives a little bit of a viewers. I don't think there's any restriction on how. It's defining the problem and then applying the toolkit.
If I add to that, James, you were spot on. So we just did a project here, and James, being from Melbourne, is aware. Victoria has quite a few large infrastructure projects. One of them is what's called the rail replacement project, where a lot of our train lines which go over the road are being sort of replaced to either go under or like a bridge. The digital concrete, that's a very interesting thing, because we did a very detailed process mapping with a few players in the supply chain. And the interesting outcome that came out of that is those systems still can't talk to each other. So it's still manually people picking up a phone and saying, where is my concrete? Where is it arriving? And if it doesn't arrive on time at a particular destination or at the right quality, what it is. From a technology perspective, we've been working on, say, sensors that can look at curing time, that can look at the actual quantity of water you're adding to it. There is technology that you can put in the cab for looking at drivers' safety perspective when they're driving these really loaded large trucks. So I can go on, and I'm sure James and probably Mook can also add a lot more from a technology perspective. But to me, it comes down to some of those systems and the processes that they have in place, which are still, it's not hard to change, but let's say it's a challenge. And that's where we need to start working with. In terms of the quality, like I said, we've done a project around the food processing line, food paste consistency, where we looked at a whole lot of data that comes from the machine and also from the operator's knowledge, and machine learning and AI, all those terms come in together to actually in real time provide the operator the right settings that the machine needs to be doing. And the outcomes for us, for example, we were able to cut down the startup time by almost 50%. And we were able to produce the product consistency by over 20%. But one thing that often, again, people think, and when they come and talk to me, great machine learning, great AI, I just tell them it's not magic. If you give it crap, it gives you crap. So it starts from what data you're teaching it to learn from, how you're collecting the data, how you're mapping it, and what outcomes you can get out of. But in the digital concrete area, I think there's a lot of technology that's sort of going in and implementation, and happy to have a separate chat later on that we could discuss. But yeah, that's wanted to add to what James had.
Yeah, thank you. Thanks, James, and thanks, Dr. Prem. Building on that, right? Maybe because so we have people from industry, academia, everyone in the panel. Fortunate to have a good combination of all types of expert. Han Young, to you, how some of these manufacturers, right, who are beginning of their journey, can work with academia, right, to help build smart factories. If you can provide some examples where you have come across, and maybe Dr. Prem can also add on top after that. How do you see on the other side being in the academia? So Han Young, over to you on.
Yeah, thank you, sir. So basically, yes, I shared earlier, actually, SME, we cannot do it alone with our limited resources. Therefore, actually, we need to find good partners that actually we can work towards a common goal, which can benefit all stakeholders. Therefore, I believe For a start, of course, this approach can help us to mitigate risk. We are actually basically sharing resources. Then actually we can learn together. And then ultimately when so-called this prototype is successful, the users can start to invest in similar solutions, so-called in a way that we can shorten our learning curve. So for example, for Anwar, actually, we have been working closely with school, Singapore Polytechnic, for the last 3 years. So basically, this collaboration, actually, we, as a user, we share our product, our process know-how to the school, and then actually they build capabilities using 4.0 solutions to automate, so-called, and produce our products, so-called as a reference to the industry. Therefore, actually, we indeed learn from this collaboration, and then we invest in our actually first robotic solutions after this collaboration. So basically, this is an example that actually as a user SME that we can learn from this collaboration from academy. So actually the second example is more exciting for us. Actually the collaboration is working very well, moving very fast. So actually beyond hardware and software integration, we are actually doing a pretty ambitious plan. We are trying to create interactive lights out manufacturing techniques that can accommodate to order changes immediately to automate our 3D models, manufacturing and inspection program on the fly. So basically, we can see the potential of reducing 1 day of work with 3 engineers to just 10 minutes of this automation. Therefore, we can see the potential that once you embark on this journey, start small, start reasonable expectations, then once you grow, you gain the confidence actually to take in more complicated and more complex projects that actually can help the users and help the company to scale. So basically, this is what I can share. Yeah, back to you, Sadiq.
Okay, thank you. Dr. Prem, do you want to add on this academia collaboration?
Sure. I think the panel here is a very good example of that collaboration in progress already, and large organizations like Cisco and so things talking about what they are doing more openly collaboration, and Swinburne's got collaboration with Cisco already. So from our perspective, Swinburne established what's called the Industry 4 Manufacturing Hub a few years back, and that was in partnership with several organizations, including Siemens and a whole lot of other partners. And the main objective of that was for us to increase awareness of Industry 4 within SME markets and manufacturers. And the program included a whole lot of webinars that people could sort of attend to get them knowledgeable on technologies. And as a part of that, we also within Swinburne, we've got our own framework that we have licensed from the Fraunhofer in Germany. And we use that to conduct what's called an Industry 4 readiness assessment. The biggest benefit for us is we are not at their door to sell a technology. It's not an auditing piece as well. It's more to increase awareness, and it helps companies really to start from scratch to think through what they would like to sort of look at a journey of digital transformation look like under the Industry 4 umbrella. And it's not that they need to perform really great in some areas or another. And we've often found out that at the end of that journey, companies find out that they are still paper-based. And there is already a lot of solutions from many different providers where you could sort of capture a lot of this data using tablets on the machine floor. And all of this is available through your ERP systems. And depending on the size of the companies we talk to, SMEs, often they're quite busy in what they're doing. They do a very good job in what they are meant to be doing, right? So it helps them understand this. The second part of this, they actually come into Swinburne normally, then they attend what we have a sort of an experiential training where they get hands-on with some of these technologies. And a third biggest benefit for us is, and I think, I do know James had it in the slide around the training the workforce, because a lot of our students become interns in those organizations. And then, potentially they could do a project with us, but there's no strings attached. But end of the day, these students actually work on the site, learn those technologies, and we get a lot of insights into what are those next gen technologies that we need to get our students trained on, because what we're actually training is their next generation workforce. While for us, they are students, for them, they are the next employee who's going to come in and start working on all these technologies. And by far, all of these technologies, while we are trying to make it simple, no code, click a button and do it, you still need skills to be able to do that. And that's very, very critical. And I think that's where the collaboration comes, because it can't be just done by university alone or just by the industry. I think it's a collaborative approach where we all come in, share our learnings to help create that next market.
Thank you. Thanks, Dr. Prem. Maybe last few discussion points, right, before we wrap up. James, I think you have given many examples, maybe building on that. So what is your most favorite smart factory use case, if you have to highlight, where you see a significant business benefit that a customer or a manufacturer got at the end?
That's a great question. I think for me personally, it's the application and adoption of computer vision or AI and ML technologies. It's an area that I've got a keen interest in, but also I really like Dr. Prim's point around garbage in, garbage out, because that is absolutely the truth, and it's not an easy process. So one of the things we're trying to do is really afford a platform to drive that. But I think the application of the thing that really excites me is chatting with customers. I can't even imagine to come up with the different use cases that they present to us and share and say, oh, look, we're thinking about this. Is this something we could achieve? And it blows your mind. Like, I'll give you an example. We've got one customer using cameras to look at coffee plant yields based on environmental conditions. Now, that I would have never thought about that, right? So, and it's really about understanding what's possible and then understanding how to apply it. And I guess the last point, there's been a lot of talk around, how do we kind of get started? One of the things I guess that Meraki looks to do is provide that digital plumbing, right? It's the starting point that allows you to deliver essentially an outcome on top of. And you need to make sure you can do that at scale in a secure way, but then also, underpin those needs with a toolkit. So I think, for me, it's about making those capabilities accessible, i.e. AI and ML, and then actually seeing what customers, want to create. For me, that's the really exciting part of the future in this space.
Okay, thanks. I like that digital plumbing. Very meaningful. So one of the topics that we see, and as I meet my clients as well, is the sustainability, right? Everyone is pressurized to produce products sustainably because customers are expecting the education about sustainability, and the need for sustainability has increased ever before. So what are some of the smart factory initiatives manufacturers can do for sustainable manufacturing? Dr. Prem, you have any thoughts, or James, whoever want to add?
I can start first. We've been doing some work more from the clean energy perspective. So there's a lot of talks about hydrogen revived recently that can help you with using much cleaner fuels. So sustainability from that perspective in terms of the things that go in. The other one, I have an example with a customer where they actually used an IoT solution just to monitor the energy usage of the plant. And prior to that, their average bill on a month was about $200,000. And they just had machines turned on over the weekend just because, and they had no idea why it was on. And that data gave them insights on that. Why is that machine actually turned on when there's no production schedule for that particular machine? So, and this is a very simple, and I'm sure James and Hon Yung can actually add to that, is that it's not any complications here, but it's just the data that comes out of that level of detail can give you a lot of insights on why am I running this machine at this particular level. There's a lot of work that we've done also in terms of looking at energy patterns to identify machines that are actually not running efficiently, because a lot of these new age machines that are coming through are quite efficient in terms of how they run. But you could look at the energy patterns to see how things are changing. On the other side, there is a lot on where I know we do work in terms of even much improved materials. I mentioned, design for sustainability, where we're looking at lightweight materials, and more in the aerospace industry, where we could look at, going from design perspective to look at designing these for aircraft and components and parts that can actually be much more sustainable in terms of the design. And I was actually looking at one here in terms of the precast plants. And I do know, for example, we do a lot of 3D printing of concrete. While you've got 3D printing of materials, and we do a lot of work in that material space of composites 3D printing. So injection molding is still quite expensive, and there is work where you could try and come up with a mold by using really minimal data. So from an AI technology perspective, there's a new stream of work, what's called, rather than big data, it's called lean data. So if you look at a typical chemistry, you conduct experiments and you try and find the most optimal point, but you need a lot of experiments to come to your more optimum. How can you come to your optimum with minimal data rather than saying big data? So IoT, to me, to some extent, it's like that. If you have minimal data, can you still optimize some of your production plans to be more sustainable so that you produce certain products at certain time and vice versa? I don't know, James, and if you want to add to that.
Oh, look, the only thing I'll really quickly add is just an extension to your point around the monitoring the environment. So one of the things we saw in say a lot of data center deployments is like, are we calling these locations effectively? How can we reduce our energy costs, and how do we be more efficient around what we're doing? So those initiatives, we can represent these things using what's called psychometric charts, which aligns, energy usage profiles to determine whether or not we can use natural cooling to actually, achieve particular outcomes. So I think it comes back to the same point, and that is the data. It's how do we collect the data? How do we do that in a way, and then apply it to achieve the goal?
Absolutely. Hong Young, you want to add anything on the sustainability? What you see, some of the
Yeah, actually, on our end, actually, we are doing fabrication of our tooling. So basically, we are looking particularly into the circular economy concept. That when we design our things, probably we are trying to see how we can use back the 3R, how we can reuse them, recycle, and probably how to reduce the waste. So this is probably that we are trying to introduce this to the industry in the near future.
Awesome. Yeah. Thanks, everyone. I think we are nearing the closure. So it was a great session. I think we covered all aspects of a smart factory in a very short span of time, including how companies can collaborate with the academia and get some benefited of wealth of knowledge that sits within the academia, and what are some of the use cases, solutions, real life examples, and of course the topic of sustainability, which is becoming increasingly important. I think it was in a nutshell, it was a comprehensive discussion. Thanks for the panel, and thanks audience for being with us. I hope you got benefited from the session. Thanks everyone. Over to you, Nisha.
Thank you, Sadvik and his fellow panelists for the very fruitful conversation. If you're in Sydney, do link up with James, and if you're in Melbourne, do link up with Prem. I've personally been to Swinburne University, and they've got very interesting lab and also technology display at their university. And if you're in Singapore, please link up with Mr. Mok Hong Yong, and I'm sure they will be able to help you with your transformation journey with some questions and answers. You'll be set on the right path. Now, if you're anywhere else in the world, do link them up on LinkedIn, and I think that will be a good network to start this conversation going. Now, with that, if there are any unanswered questions, do let us know, and we will send them to the respective speakers, who will then liaise with you via email. With that, we conclude the webinar today. We hope today's session has been thought-provoking and meaningful. If you wish to know how you can learn and gain more insightful knowledge around these technologies, do join us at ITAP in Singapore from 18 to 20 October 2022. Thank you and have a great day ahead.